Hi guys, welcome to the first video of interview preparation series. The topic of discussion for this video is Introduction to Recursion. By the end of this video, you will have a clear idea about what recursion is, how recursive algorithms work, and the stack representation of function calling in recursion. So let's get started. So let's start off by understanding what recursion is. Recursion is a method of solving a problem where the solution depends on the solutions to smaller instances of the same problem. So as I said in my previous webinar, that when you have a given problem, let's say you have an array of size 4 and you break it down into smaller parts and you solve it. You solve for this part, then you solve for this, and then you put all the solutions together. So that is what recursion is. So if the problem can be broken down into smaller versions of itself, then we may be able to find a solution to solve one of these smaller versions and build up a solution to solve the entire problem. So what does that mean? It is very much analogous to our differentiation and integration concepts that we have learned. So when you have a given problem, you are going to break it down into smaller parts and you're going to solve each and every of those parts. So let me call this method as differentiation. And after solving each and every smaller part, we are going to put them back together to get the solution of the entire problem. So let me call this integration. All right. So this recursion, it works on your divide and conquer strategy. So this is nothing but your differentiation and integration put together. So now let's find out how these recursive algorithms work. So as I said in the previous slide, recursive algorithms is nothing but breaking down a bigger problem into much smaller ones and finding the solution for that smaller problem and then integrating it to get the solution for the entire problem. So let's say let me give you an example of where I have to manufacture 500 t-shirts. Now I'm going to tell the computer how to manufacture one t-shirt. I'm not going to sit and do it for all the 500, right? So I'm going to tell how this one piece is done. I'm going to give it a logic, the methods it should apply, the measurements it needs, and all the technicalities. And I'm going to say, okay, I'm manufacturing one t-shirt, you manufacture 499 t-shirts, and give it back to me. So this is exactly how recursion works, like let's say let's take the example of a merge sort. So given an array, what do? Say we have 2 3 1 4. All right, so we are going to first break it down into smaller ones. So initially it's 2 3 and we have 1 4, and then again we break it down into 2 and 3, and then we have 1 and 4 over here. All right, so what do we do while solving this? When this is your dividing, that is your differentiation. All right, now when we are solving it, we go from down to up. We compare these two, 2 and 3. So we see that, let's say I want to sort it in ascending order, right? So we're going to compare 2 and 3. So 2 is smaller, so we're going to have 2 first and then followed by 3. All right, now we're going to come to this side. So this place is sorted, this side is sorted. Now we're going to come to this side. So we're going to see 1 and 4, that is again already sorted. So we have 1 and 4. So this side is already sorted. Now when we come to the next step, when we are taking this one and this one and we're trying to sort it, so what do? We compare 1 and 2. 1 is smaller, definitely, so 1 should come first. Then after that we compare 4 and 2. We see that 2 is smaller, so 2 should come second. Then we compare 4 and 3, so 3 comes next, and then we have 4. So thus this will give us our sorted array. Right, so this again uses our divide and conquer strategy, which is recursion. So you keep breaking down the array till we reach only one element, and then we start merging them by using sorting logic. All right, so now let's see the stack representation. So this one I'm going to explain with the help of the factorial example. All right, so what is a factorial? All of you must have an idea, because this is something which we have learned in mathematics long time back. Factorial of any positive integer n is denoted by this. So n followed by exclamatory mark. All right, so what is this n factorial? N factorial is nothing but the product of all the positive integers which are less than or equal to n. So if we put this definition mathematically, we see that n factorial is this: n into n minus 1 into n minus 2 till 3 into 2 into 1. Now let's look at it in a different approach using divide and conquer. Instead of seeing it as an entire problem, let's break it down. So how are we going to break it down? We see that this is n, and again followed by n minus 1, n minus 2 and n minus 3. Now when you take only this part, what do we see? This is nothing but n minus 1 factorial, right? So n factorial can also be written as n into n minus 1 factorial. All right, so similarly n minus 1 factorial can be written as n minus 1 into n minus 2 factorial, and so on. All right, now this is fine. We have found out the logic of how to calculate the factorial, but when do we stop? We need to have a stopping condition, else this is going to go into infinite loop, because we keep calling n minus 1 and then n minus 2, it keeps going. So when do we stop? That is where base condition comes to play. So when you have a problem for which you need to solve using recursion, so there are two things which you need to keep in mind. First, these are the two most important things. First, your base condition, and second, the logic. If any one of these is not right, your function won't work. No matter what, let's say your logic is perfectly fine, but you messed up in your base condition. So in that case, your function won't work. It will give you a wrong answer. It might give you a time limit exception. It can go to infinite loop. You will get the wrong answer. So whenever you're coding something in recursion, always make sure that your base case is correct, and also your logic. Neglecting even one of these will give you a wrong answer. All right, so now let's see how this factorial of a number is going to be calculated in the computer memory. That is, you all might be aware that we have heap memory for storing all the variables, right? But when we come to calling functions, then we use stack. So let's find out how that happens. So let's say I want to calculate the factorial of 5, right? Now this is my factorial function, right? So this is our stack memory. So how is this going to be called? Like, how does the compiler know which function to be called after which value, the output value is to be used for which part of the code execution? So that is what we're going to see right now. So let's say I want to calculate factorial of 5. So first things first, we have our main function. Our main function is going to call our factorial function. Let's say this is our factorial function, and inside this we have our code. We'll figure that out later. So this factorial function is going to be called from the main function. Now when we come to factorial of 5, what did we see? We saw that n factorial is n into n minus 1 factorial. So how do you think it's going to be called? It's going to say that, okay, alright, I have n, but I need the value of n minus 1 factorial. Now why should I sit and calculate that? Let the computer do it, because I have already given the logic. This is how you're supposed to calculate it. So what I'm going to say is, alright, I'm going to call the function again for n minus 1. So this, my work is done till here. That's it. I'm just going to ask the computer to calculate the rest of the part and give me the answer, right? So what happens here is factorial of 5 is broken into 5 into factorial of 4. Now similarly again this factorial of 4 function is encountered. So what is going to happen? It's going to follow the exact same procedure which it followed when it called factorial of 5 from the main function, right? So this factorial of 4 is going to be called and it's going to get added over here as factorial of 4. So there you go. Again, 4 can be broken down into 4 into factorial of 3. So that is what is going to happen. And factorial 3 again will be broken down into 3 into factorial of 2. Similarly for factorial of 2. And then we reach factorial of 1. Now, remember our initial definition of factorial. Factorial can be calculated only for positive numbers. So now we have reached 1. Right? So after that we have 0 and then we have negative numbers. So that won't be counted. So if I call a function for, let's say, factorial of minus 1, this should be wrong. But who's going to tell the computer that? The computer does not know what you're calculating. It's just doing the exact work what you're saying it to do. So who's going to tell the computer that, okay, you need to stop here? This is where base condition comes to play. So we inside the function, here we're going to have a base condition where I'm going to say if my n is equal to 1, then what should it return? We know that 1 factorial is 1. It's a known fact. So then I'm going to say, okay, now you have reached 1, then you should return 1, right? And the rest of the cases, what should it do? It should return n into factorial of n minus 1. That's it. Your function is going to be this simple. So you're going to have your base case over here and you're going to have your logic over here. So now this is going to return 1. This is going to compute it as 2 into 1 equal to 2. Then that's going to return 2. 3 into 2 equal to 6. This is going to return 6. 4 into 6 is 24. And 5 into 24 is 120. So we get the answer as 5 factorial equal to 120, right? So this is how our factorial function works. This is how the functions get called in the memory. You have stack representation. One is on the top of the other. And when one function is executed, the answer is returned and the other function is resumed. So this is just like your interrupt. When I'm calling the function from here, 5 into factorial of 4, when it's calling 4, then this execution is stopped. That is how interrupts work. And now when it gets back the answer, it is resumed. So it calculates 5 into 24 is 120, right? So this is how the logic works. So we're going to code in the next video. So this was the introduction video. In the next video, we're going to code this very problem. So there is a drawback when you use integer as return type for this function. You saw we were returning n and returning 1, right? So if we use integer as a return type for this function, it has a drawback. I will tell you what it is in the next video, and we're also going to find out how to overcome that drawback and how to get the answer, required answer for the different values of n. I hope you guys have got a clear idea about what recursion is, and especially the stack representation of function calling. Please let me know what you think about this video, and if you have any doubts, please ask me in the comment section. You can also join the Telegram group in which I am in. There I can clear your doubts and also share some tips regularly for interview preparation. Also, if you guys like this video, please give it a thumbs up, and don't forget to subscribe to this channel. You'll get regular updates as and when I keep posting more videos, which I will, because after this interview preparation course for coding, we are also coming up with a similar course for aptitude as well as technical. And the most exciting parts about these courses would be that they are, of course, absolutely free, and you'll also have regular tests and contests to get an idea about how well your progress is. It's going to be like a progress tracker. And not only that, I will also be discussing all the solutions within a day or two of the contest. So I guess this is going to help you. I hope this helps you guys a lot. So see you all very soon in the next video. Take care.